Hi folks, in this video we are going to learn about fraction concept. So focus is going to be on developing conceptual understanding. We will use several daily life examples to develop our conceptual understanding, and we'll also reason out how the processes or procedures we use to write fraction and use fraction, how these work. So reasoning is core of mathematics. We'll be doing that, and some basic level problems that we can solve at conceptual level. So that's the focus of this video. Okay, so what is the concept of fraction? Okay, so to understand it at a very basic level, let's look at this figure. This figure shows a whole has been divided into three equal parts. So one, two, three parts. And from our daily life experiences, we know when we divide a whole into three parts, we call each one third part, third part. But how do we write that? How do we write it? It is actually fraction in fractional form. We can write that in decimals, but that's not the focus. In this video is just fraction. So here you can see one, that means this is a one part, so we want to show that here, so we just write one. But then how we decide or determine that this one is a third? Well, for that what we do is just put a line here and write 3 below that line. Okay, so this 3 below that line actually says that this part shown here above this fraction line is a one part and its size is a third because it is taken from a whole which was divided into equal three parts. Okay, so that is the function of here. We show parts here, and basically below the fraction line we put here the total parts of a whole, which shows the size of the part here in numerator. So we call this part numerator, and this number here below the line denominator. So numerator is the number of parts or parts that we want to show, and then the denominator shows the size of the parts here by showing that how many equal parts the whole was divided. So in this case, whole was divided in three equal parts. So one part here is a one third, and the same way this is one third and this is one third. Okay, so what if we just want to write these three parts together? Well, following this logic, we write 3 in the numerator now. Denominator stays same like it was here because now we should want to show three parts here. All of these three parts. So we just say 3, we write 3 in the numerator, and denominator stays the same, which is 3, which shows that each part is one third. So because the three parts together they make a whole, so they are equal to 1 because equal 1 is whole. Okay. Well, what if we add more parts? Let's say we add two more parts. Now there are 1, 2, 3, 4, 5 thirds. How we write them? Simple. We just say 5 over 3. So notice here the denominator is still same, which was here 3 and here. Now the number in numerator has changed because we want to show 5 parts, 5 thirds. 1, 2, 3, 4, 5. We want to show all these 5 thirds here in this fraction. So that's why we just say 5 thirds. We can also write that one whole and 2 thirds. That's also fine. We call it a mixed fraction. I'm going to discuss this further. So one whole and 2 thirds. Alright, so let's build further on this concept of fraction, where we discuss that we want to write the parts in numerator, that the parts that we want to show, and then the size of part is determined by the denominator. So this here in this case this is 1/4. So we want to show one part, and the size of that part is determined by this denominator where we have it in 4. That means the whole was divided into 4 equal parts, and one such part we want to show here. So this is 1/4. All right. So let's look at such other examples. So this is 1/4 we saw here. So this is the one part we want to show, and its size is 4th because whole was divided into 4 parts. But this is 2/4. We are not changing the denominator here. It is same. So 2/4, 3/4, 4/4, right? 5/4, 6/4, 7/4, 8/4, So see, we are changing number in numerator. So basically we want to show more parts, but the size of the part is same because denominator is 4 and therefore 4 in denominator means that each part is a fourth. So in this case these are 8 fourths, and 8 fourths altogether are equal to 2. But what if we want to write 250 fourths? Well, we just remove 8 and write here 250 and over 4. So 4 stays same because we want to write fourths. 250 fourths, we just say 250 here. So we can write any number of fourths by following this logic. Okay, let's look from another perspective as well. So here what we are doing now is we are keeping one part in numerator, but we are changing its size. So in this case, this is one part, but this one is actually half because denominator shows 2, which means that whole was divided into two equal parts, and one such part we want to show here. Okay, so this one here is 1/3, this one is 1/4, this one is 1/5 because 5 equal parts, it is out of 5 equal parts. So this here is 1/6 and 1/7. So that way, we can write. Here you can see that the one part that we want to show in all these fractions has different sizes because denominator is different, and denominator decides or determines the size of the part or parts we want to show in the numerator. Okay, so what we learned from this discussion that fraction means a part of a whole. Okay, so fraction we use to write parts and in reference to a whole or from a whole. And fraction has two numbers, one above the line and one below the line. So one below the line is denominator, which shows size of a part by showing total number of parts in a whole. Okay, and all parts are equal. Remember this, because if parts are different, we cannot again determine, so that's illogical. So we have to keep all parts equal, so we make all parts equal. Okay, and numerator, which is the number above the fraction line, shows the number of such parts. So denominator shows size of a part by showing total number of parts in a whole, and numerator shows such parts. So such parts can be any number of parts: 2, 3, 500, 1000, 2000, 6000. So let's say denominator is 2. Okay, so 2 means the whole has been divided into two parts, and such parts we want to show in numerator, and we can show any number of halves. Um, so that's the idea. Okay, so let's look at some real examples. So this is half an apple. We can see half here. So how we show? So this is one half. So we just write one here. But then how we show half? We put 2 in the denominator, which says that this apple was divided in two equal parts, and one such part we have here. So we just read this as half apple. Okay. So 1/2 means half. Okay, how about this? Well, this is 3/4 watermelon. How we determine this is 3/4? Well, from this part we can say this 1/4 has been taken out, so the remaining is 3/4. So if 1/4 is taken out, that means, so if we divide this whole watermelon into 4 equal parts, one such part has been already taken out, and 3 parts are remaining, even though these 3 parts have not been shown separately, but we know their worth or value is the remaining watermelon is 3/4, so we write 3/4. Okay, so this is how it works when we use in our daily life. Okay, so let's look at some more daily life examples. These are garlic nuts. Here we can see, and from the image we can see that these are halves. Okay, and these are 4 halves. So let's say these are 4 halves. Let's consider this as half as well. So how we write 4 halves? Well, we write 2 in the denominator. That shows that each part we want to show here is a half, and we just write 4 here. That says that these are 4 halves. So 4/2 is 4 halves. And since 4 halves are equal to 2 whole nons, so we can just say it is equal to 2 halves. But what if we just want to write 1 half? 1 half. So 1 half is 1 over 2. And notice here that the denominator is same here, 2 and 2 here. So 2 denominator means that part we want to show here is a half. So in this case, we have written 1 in the numerator. That means this is 1 half, and 4 times 1 half is equal to also 2. So the overall value of this whole garlic naan we see here in the image is 2 garlic naans or 4 halves. Okay, let's look at this pizza example. Okay, these are 8 parts, so we can just say whole pizza is divided into 8 equal parts, and if we want to show all of them, we just write 8 here. So it is 8 over 8, that means whole pizza, right? 8 eighth parts. But what if we want to just show this eighth part? Well, we can just say 1 over 8, and then 1 eighth part 8 times is equal to 1. Okay, so we can write 1 eighth such 1 eighth parts 8 times, and we multiplying 1 eighth by 8 is also 8 times, so that's equal to 1. So this is how it works, right? Okay, so some more examples. I just want to see some more real life examples. Now in this case we have 2 apple halves. So that means we have a whole apple, but if we want to write 2 apples, 2 halves, how we write? We just say 2 over 2. So this 2 here in denominator says that apple is divided into 2 parts, okay, and we want to show such 2 parts, so that's why we write 2 in numerator as well. Okay, so it is 2 over 2, so this means 2 halves are 2 halves, and that's equal to 1 because this 2 halves are equal to whole 1 apple. Okay, what about this watermelon? Well, how can we write there? Well, if we want to write this is 3/4, although it is not cut into 3 different fourths, but we can see from here that 1/4 has been taken out here, so remaining is 3/4. We can write 3/4 here, and then we can write 1/4 here, and altogether it is 4/4 and equal to 1. So the whole watermelon is 1 or 4/4, and 3/4 we can write this. So I just want to deliberately show you this here. This is not cut into fourth parts, but we know the value here is 3/4 because in reference to this part 1/4 has been taken out. So that means remaining is 3/4. Okay, and if we add both 3/4, 1/4, it is 4/4 and equal to 1. Okay, so this number line here also helps us to understand fractions. Now, see, in number lines there is a 0 and then the next number is 1. So 0 means nothing and 1 that means there is one thing, anything. But do we have numbers in between these? Do we have numbers which are greater than 0 but less than 1? Yes. For example, half here. Half is greater than 0, but half is less than 1, and it is basically somewhere in the middle in this number line. So all the proper fractions actually, and their number can be indefinite, they all fall between 1 and 0. They are less than 1, but they are greater than 0. So there could be lots of fractions here which value is less than 0, was less than 1, sorry, but greater than 0. And the same way we can have lots of fractions here where the value is greater than 1 but less than 2. So in this case, for example, 3 halves. 3 halves is more than 1 or greater than 1 because it has 3 halves. So 2 halves make 1. So 1 half is more than 1, but it is less than 2. So 2 is 4 halves. The same way, five halves are actually less than 3 but more than 2. So in this way there are lots of fractions here too. So number line is a good way to kind of understand that there are there are lots of fractions basically in between these um, whole numbers that we actually use in our daily lives too. Here are some more examples how we use fractions in our daily lives. For example, we can say 500,000 people work as teachers. So we just half instead of writing half in words, we can say 1 over 2. That means half. Half population is women. 2/5 students are enrolled in pre-engineering courses. Okay. 2/5 cake. So if cake is divided into 5 equal parts, two such parts. 1/8 mile, 1/6 funds, and 2/3 rooms. So we can use any. So when we use, we call this fraction and we call fractions unit. So this in this case 2/5 is cake. So there could be 2/5 students, right? There could be 2/5 millions. So fraction and their unit, that's how we use in our daily life. Okay, so we can divide numerator by denominator and let's discuss why. Okay, so 3/3, we divide numerator 3 by 3 and we get 1. So we know 3/3 are equal to 1. Okay, let's look at this. 8/2, we divide 8 by 2 and we get 4. Okay, so we know that 8/2 are equal to 4. We saw earlier in earlier example too. So this figure just shows that this is true. These are 3/3 and they are equal to whole. So this is how we develop this rule that we can divide numerator by denominator. Let's look at some more examples. 5/3, we divide 5 by 3, we get 1 whole. 1 whole by 3/3 and remaining 2/3 we can write like this, and this is called mixed fraction. So 1 divided by 2 and we get 0.5 in decimal, which is also equal to half, and 1 divided by 1 is equal to 1. So this way we can divide numerator by denominator, and that helps us to change a fraction into whole number or in a decimal. Okay, so two or more fractions can be equal in value. We call them equivalent fractions. So let's look at this example. So we remember 1/3, 1/3 and 1/3, but what if we just divide 1/3 into equal two parts? So then this whole becomes 6 parts and each part then becomes 1/6. So 1/6 here, 1/6 here. So each 1/3 is divided into 2/6. So that is what we can write here. So 1/3 is equal to 2/6. So each 1/3 is divided into 2/6. Okay, because the whole in terms of 6 parts, this whole is 6 parts, and then these 2/6 are equal to 1/3. That's why these 1/3 and 2/6 are equal. Okay, and 2/3, right? 1/3 and 1/3, and in these 2/3 we see 4/6. We can write 4/6. The same way 3/3 are equal to 6/6. So 3/3 are 1 and 6/6 are also a whole 1. So this is another idea where we can write fractions, although their numerator and denominator numbers could be different, but their values are equal, and we call them equivalent fractions. Okay, so I have been saying this here and there in the earlier discussion. So fractions can be proper fractions. Proper fractions are where numerator is less than denominator. So in all these examples, we can see numerator is less than denominator. Okay, so we kind of give them name. We call them proper fractions. Why we call them proper fractions? Because they are less than 1. I think that's why they gave this proper name. Because initially when humans conceptualized fractions, they thought that something which is less than 1 whole, how can we write that? But then we knew that we can write improper fractions as well, because in improper fractions the numerator is greater than denominator. So this is perfectly right. These all are fractions. And why we call them improper? Because the numerator is greater than denominator. So numerator is actually greater than a whole. The denominator shows the whole, like 3 parts in a whole in this case, and 4 parts are shown. That means it is more than whole. So that's probably they call it improper fraction. So there are mixed fractions too, where you have wholes and their parts. These are instances. These are mixed fractions. Okay, so here are some examples for you to work on. Uh, Proper fractions, improper fractions, and mixed fractions that we have discussed briefly. You can try and work on. And if you cannot figure out, watch some more videos on solving these problems and some more problems. So here are our key learning points. Fraction means part of a whole. We discussed that. So when we have to write parts, we use fractions. Numerator shows parts and denominator shows size of a part. All parts shown in a fraction are equal. So that's a very important point to remember, because if parts are not equal, then we cannot write them in the same fraction. Numerator can be divided by denominator change into decimals or mixed fractions, and fractions can be equivalent in their value. Okay, so here are these figures. You can use the value in these figures. This is exercise for you. Just write the fractions for each figure, and watch more videos to see the solutions of some of those problems that you saw in the last slides, and follow us on um, uh, Facebook and subscribe our channel on YouTube. And happy learning math.